what I want to do, I'm hopefully a lot of you will remember me from the previous winter school. What I want to do is I'm going to recap basically on some of my motivation and say why I'm interested in this area and what I'm trying to do. And then I'm going to move into talking a bit more about, effectively by revisiting that previous project, I'm going to tell you what we've done next. And in essence, this has involved taking it into the eye tracking world and introducing eye tracking into 360-degree video. And I want to talk about this from two perspectives. One, from analyzing user behavior, which I think is the most common use of eye tracking. It makes sense that most of the things we're doing with eye tracking is trying to understand what people are doing. But there's also a big market, I think, coming up where actually, if you've got eye tracking available to you in your end product, maybe there are things you can do with eye tracking to build attentive user interfaces where the computer actually knows what you're looking at, and so it can respond appropriately. And so we're going to talk a bit about that as well. And the main focus of what I want to do, really, I suspect everyone's had death by PowerPoint for quite a while now. And so I'm going to basically attempt to show you some of this stuff live. I'm going to show you some of the things we've built in Unity, expose you a little bit to Unity, those people that haven't used it before, so you see a little bit what it looks like, how you build things in it, and how our solution runs within that. And hopefully by doing that, it will give you a little bit of exposure to actually how you can start building some of these projects. Things like Unity, if you've not used it before, actually isn't as bad as it looks to begin with. It's one of those environments that looks absolutely horrific when you open it up, but actually you can build user studies and things using Unity relatively easily by pulling building blocks together. And so I just want to show you a little bit of that. And of course, it's much more exciting to try and do a live demo, particularly when your kind of office is in ruins and we've got bits of kit lying around. So hopefully it will work, and hopefully I can get all the tracking and things to demonstrate live for you today. So I like to start all of these talks by introducing myself, really, and saying I am a technologist. I'm not a user study expert. I'm not an eye tracking expert. Like most of the people at this event, in fact, I hadn't touched eye tracking before I met Chris and people and got involved in a study where we needed to use eye tracking. And so it's very kind of him to call me a magician, but actually I'm just the kind of person that can take different bits of technology and bolt them together. And so we have an eye tracking expert tells me how to do eye tracking. I can suddenly build it. And I like to sit in this kind of bubble because it means I can interface into different worlds. I first got involved as a technologist in research in the medical training world, where I was building medical applications in virtual reality. Now I'm looking at studies for how subtitles work within virtual reality. And so it's a really cool place to be, being the guy that can bolt things together and build demos and put things together quickly. And it's great to then be able to work in different interdisciplinary teams and see how those kind of things work. But anyway, I want to jump back into, hopefully you'll remember me from the last, the winter school. I'm trying to remember what season we're in now, where we actually, I introduced a lot of the work I'd done before. And I talked a bit about my motivation, saying, actually, subtitles are cool. They work on television, 2 lines of text. But as soon as we move them into a different medium, it doesn't quite work the same. If you're still trying to stick with 2 lines of text, 30 characters wide, when you watch it on your mobile phone, it doesn't really work. And also my motivation behind it all was, well, what then happens when you move into virtual reality, where you can put things any way you like? You can put the caption behind people if you so wished. And also what happens when you have all sorts of different assets and things like that in the scene? It starts to get quite confusing how you lay things up together. And so suddenly this was a very interesting area to work in. And so I jumped in with 2 feet, basically looking at how you can understand users' behavior and build better interfaces in 360-degree video. So all of a sudden, we're taking the world that most of us are used to with a two-dimensional television in the corner of the room and effectively wrapping it all around someone's head, and so giving them complete freedom as to where to look. And I introduced in that last talk a bit about some of the challenges that I see within my interest in that area, the subtitling. So for example, where can you put captions within the display of a head-mounted display? What fonts, text sizes work? Where can you actually render things? And then it gets a lot deeper. So that's kind of the practical element of how does it physically work with the display. But then all of a sudden you realize, well, the person speaking could be stood behind. How do you actually direct people to that? How do you understand where they are? And more fundamental to everything is when you get to the lowest level, you start talking about narrative. So I have a director who's produced a piece of media. They want to put it out to their audience. Do the audience understand the narrative if suddenly you can't hear the sound? Does it still work? And how can we test this? And so I've showed a few examples. I talked a bit about, well, head-mounted displays, the quality isn't all that good. So we need to understand, actually, if you put a caption at the edge, do people still read it? Can they still understand what's going on at the edges where the image quality falls off? And as I've mentioned, things like the actual speaker identification. If you've got a subtitle at the bottom of the screen, it doesn't necessarily mean it relates to the person that you're looking at. Could be the person stood behind you. And so in that last workshop, I showed you an example of an interface that we'd built. So my entire focus of the last workshop was talking about rapid prototyping. If we build something quickly, we can actually put it in front of a user and get them to use it. And I guess that's where I come into this world quite successfully, and people call me a magician. I'm really not. I'm just someone that can build a demo overnight of something so that the next day we can put it in someone's hands and say, does this work for you? Can we reevaluate it? And can we take that further? And we defined a whole kind of mechanism for defining where you'd put subtitles in space. If anyone's particularly interested, we use polar coordinates to define whereabouts we're going to put a caption. And so we basically say what radial distance it is away and what the coordinates are on the latitude and longitude within that space. And when I was speaking to you last, I basically showed you that we'd got to this point where we had a very nice kind of 360-degree video player that was web-based, that you could basically create captions, put them where you wanted. And we had a framework where we could effectively play with every parameter that you can imagine. So you can change things like file formats, different caption modes, different guide modes. We had modes built in to do creative captioning, and all these kind of things. So we had a framework that you could put in front of someone and they could actually tweak all of these parameters to try and find a setup that worked for them. And I showed you a few examples. So for example, captions could suddenly now be fixed to the speaker. We could stack them so that if maybe we needed more time to read them, they didn't disappear instantly. We put them somewhere in the screen, but did collision detection, so it still made sense. So we were building an almost intelligent interface to the level that suddenly, if you put a caption in the space, but you want more captions, how do they avoid each other? How do you use collision detection to say, make sure they don't obscure each other? And I also showed you some stuff on responsive captioning. So this was kind of the precursor to some of the work I did with creative captioning, where actually all of a sudden you can use a natural language processing to reblock your captions in the player and have some kind of control. And I think I also showed you some stuff on actually the person speaking is stood behind you. How do we guide the person to there? And so we ended up with a framework with as many ideas as we could throw into it as ways to actually put some kind of guiding mechanism in to drive that user to the appropriate place. And I think I spoke for about 4 hours in the last workshop, and I kind of got to the point where I wanted to present you with some lessons that I had learned. So again, I'm coming into this not as a user test expert or an eye tracking expert, but someone that's fallen into this world and trying to actually find my way around and learn some of these things. And I left you at the time with 3 ideas. I said, user tests yield limited results unless you put a working product in front of someone. My experience in this area is paper prototypes confuse people, focus groups, if you sit and talk about ideas, unless they can actually see it, it often leads to confusion, and they kind of say, actually, what we've already got is pretty good, let's stick with that. I also suggested that many of these technologies have a learning step. If I hand someone a head-mounted display that's never used a head-mounted display before, all of a sudden they're confused by the environment. They don't understand. It takes time to learn how to use it, and that you can move your head around and look to see what's in there. And also I said the content was important. We ran some user tests in the past where actually we presented people with content they weren't interested in at all, and so they stopped reading the captions anyway. And it leads me to one of my favorite quotes that I always jump back with, from Henry Ford when he was inventing the car. If I'd asked people what they wanted, they would have said faster horses. This all leads to the fact that I like to say that users don't generally know what they want. It's very hard to go and ask someone that hasn't got the imagination of the entire world to basically, how would you like the captions to look within a 360-degree environment? Because they can't visualize that. They've got no basis to do that. And so you need to put things in front of them. You need to give them prototypes and ideas and then properly analyze. But what I want to do today is basically add a new observation to this list, where I basically want to say that users are pretty useless. They don't know what they want. They don't know what they do. If you show someone a video with subtitles in it, and you ask them to read us if they read the subtitles or what objects they saw, most of the time they don't know. It's possibly that this is because these tasks are done subconsciously, possibly they don't remember. But in essence, this is where we've now fallen into the world of eye tracking to actually try and analyze what those users are doing, rather than asking them and getting their feedback on what they've learned. Interestingly, I first observed this about 10 years ago when I was working in the medical field, building medical training platforms. And I spent a lot of time in medical theatres watching interventional radiologists performing procedures. And I would interview the interventional radiologist and ask, can you tell me each step of this process? So you're going to clean the area, you're going to make a small incision, you put a needle in. But they didn't know the steps that they performed. They gave me a list of things that said, well, we do this, this, this. And then I went and watched them in theatre. And actually, they didn't have a clue what they were doing. And so from my perspective, users are pretty useless, no offense to anyone. But actually, there's a massive area here for using eye tracking. Eye tracking doesn't lie. I can use eye tracking to tell exactly what a person has looked at. Whereas if you ask a clinician, did you actually anesthetize this patient first, or local anesthetic into this area? No, they've got no idea that they did that, and they could just pass that information on to the next person who wouldn't do that step. But there we are. So this leads me really onto eye tracking in 360 degrees. I started looking at how you could extend this project with a few of the people involved in this workshop. So we've got Chris, and we've got Pilar and Marta and Andrew, who I think gave a talk earlier in the week, who were interested in how we can do eye tracking within 360 degrees. So conventionally, I'm sure you've all seen conventional eye trackers now. They're high-speed cameras. They get a clear view of the user's eyes, and the eye tracking is traditionally done in a fairly fixed position in front of a monitor with a camera pointed so it can see the eyes easily. The problem with when you're trying to do it in 360 degrees is when you put a head-mounted display in front of someone, all of a sudden you can't see the eyes anymore. It becomes very hard to do. And until relatively recently, the kind of aftermarket eye trackers for head-mounted displays was quite clunky. In essence, the first times it was done, we basically had clear perspex in front of a user's eyes, and we're projecting an image onto it and pointing a camera at it as well. It wasn't particularly easy, or it made it very hard to actually do eye tracking in that environment, particularly with when the user's then wearing quite a lot of apparatus on their head. They can't really focus on the study. They're more focused on not having the head-mounted display fall off, for example. But things have changed, and relatively recently, HTC released a version of the Vive Pro, which had an eye tracker built in. And this, in eye tracking terms, for 360 degrees, is a real game changer. In essence, they are interested in being able to read facial expressions while you're an avatar in a virtual world. So HTC and the developers of the head-mounted displays are continually trying to look at ways where you can enter virtual reality and they can replicate how you look within a virtual environment. And so what they've done is they've basically built an eye tracker into the HTC Vive, with the main motivation that they can tell which direction your eyes are pointing in, whether your eyes are closed or not. And they can, from that, derive some basic facial expressions. And then when you're a virtual character in a game or a virtual environment, they can actually replicate that. And so you can see whether people are frowning or what kind of facial expressions they're currently pulling. But from our perspective, what this actually does is it gives us a very high quality eye tracker under the hood. And if you can integrate with that eye tracker, you can suddenly start to get some really good quality eye data from the head-mounted display itself. So the way they achieve this is by adding an array of infrared lights and a couple of carefully positioned cameras with very careful lenses, so that they can actually get your eye position. And it's a really interesting way of doing things, because all of a sudden we've got the eyes in a fixed position because the eye tracker is moving with you, but you can derive the pupil position within that, and which direction it's looking, and some useful things like that that we can then derive back into the gaze position. And the other interesting thing is the eye tracker in the HTC Vive Eye runs at 120 hertz, so we can actually get the data really quickly and do some useful things with it as well. Vive also provide an SDK called SR Anipal, which is, from my perspective as the developer here, still very much in development. So a lot of the development notes aren't yet complete, and a lot of the stuff under the hood hasn't yet been implemented. So although it's a really good API, when you first jump into this, if you're using this, you'll find that actually it doesn't feel complete yet, and you have to do a lot of work yourself still. There are a couple of commercial versions of it as well that you can buy. They're quite a lot of money, but do provide a lot of the functionality underneath that you need to do eye tracking. So potentially, although for our project we've dived in at the kind of development level, API level, and built our own eye tracking software, there are also commercial versions that are becoming available that you can drag and drop effectively into Unity. So the SR Anipal SDK allows developers to track, integrate users' eyes, lip movement in order to read. It's designed in essence to read intention and model the facial expressions. And it effectively gives us an additional application that runs in the computer. It starts up when we start up Unity, and it allows us to basically integrate with the eye tracker. As I said before, it gives us an interesting environment because the eye tracker is fixed to the eye, and so the eyes don't move very far within the actual window that it looks at. But it does therefore give us enough information that you can work out what direction each eye is looking at, and so you can also work out what point at which the eye's gaze converges in the distance. And so we've had a lot of fun looking at it, and we can get things like where the eye position in millimeters within the display. We can get the direction. This comes in normalized out of the API. But we can also get other useful things such as pupil diameter, how open the eye is, and whereabouts in the eye the sensor is, whereabouts in the sensor the eye is. And of course, we can do this for both eyes. And so we've basically built a Unity application around this that replicates a lot of the functionality that was within our first prototype, where we had the web-based version for doing rendering subtitles on 360-degree video. So the architecture looks a bit like this. We took a decision fairly early on that I would build two different applications. So wasn't entirely sure when we started the project how to analyze the data. And so it made sense to me, we could build two separate applications. We could build one application that is specifically designed at capturing the data. So we have the data coming from the head-mounted display. We know head orientation, we know video time code position, we know what captions are currently on the screen. We can throw all that information into a database. And so we can basically build a user study. We can put the head-mounted display on a participant. We can record all the data, but we can then build a second application that allows us to play back that data later. And by playing it back later, it means we can then completely replicate the test, and it means we can then completely decide how we want to process that data, how we want to analyze the data, what processing we want to do on it. We also hit another interesting problem with Unity and the Vive Pro, that Unity is built to run at 90 Hertz. So in essence, Unity is a computer games engine. It's designed for developing computer games. And what that does is they basically say that monitors generally run at 90 Hertz. High-end gaming monitors don't run faster than 90 Hertz. They don't refresh more than 90 times a second. And so the entire framework of Unity is based around only processing data at 90 Hertz. And so in essence, we had to build almost a separate application to the Unity application that runs at 120 Hertz to capture the data that's coming in off of the head-mounted display and the eye tracker. So in essence, we end up with this kind of scenario where we've got a separate thread that is capturing eye data and feeds it into our data management. And we have our Unity application that's running the test and recording all of the other data and throwing that into the data manager with the same time code information. We also had to build a separate caption manager that sits on the top that actually sits alongside the video and says, the next caption is displayed in this position at this time, and does the management of loading subtitles from a subtitle file and doing the actual rendering. And then, as I say, we have a completely separate playback unit where we analyze the data later. And so we basically can take the data back out of the data manager. That's the head orientation, video position, eye data, and the caption state. And we can completely play it back. And at the same time, we can generate any files that we want that need to be passed down the chain to the people that are going to actually analyze this data. So what I wanted to do, rather than be death by PowerPoint, really, and I'm aware that we're already a little bit behind your schedule, I actually wanted to show you a little bit of the Unity interface, and I wanted to show you a little bit about what we've actually built and how it works. So those of you that have never used Unity before, I'm hoping you can see my screen, and I'm hoping you can see this is what the main Unity interface looks like. When you open it up, there's a lot of stuff going on, and it can be quite complicated as to what's in there. But I would encourage anyone that's building tests and wants to go to the kind of next level in 360-degree or virtual reality to actually consider Unity as a tool for doing it. Because in essence, a lot of what's behind the scenes is drag and drop, and you can basically take components and build up different scenes. So within Unity, you find that everything's split into a sensible kind of file structure. And within that file structure, you can basically extend it in any way you want. The way I've built our application is that we have a number of subdirectories. So we have things like a data directory. Within that data directory is where we record all of the test data and all of the process data. Things like fonts within Unity have to be pre-rendered. You can't, for example, just take a font and say, I want to write text, like you could in Microsoft Word or something. If you want to render it within Unity, actually you need to render every character at every size, and then you can pick those different assets to put them together to build the actual subtitles. We then have a few other directories. So there's things like a directory that contains all the actual source code, and you'll see there are things like a separate file for doing things like the Savitsky Golay filtering that we use within the application. But we also have a script that runs things like the caption update. We have a script that runs the data manager and stores all the data and those kind of things. And finally, the interesting one is we also have a subdirectory where we store a series of scenes. And as I said before, we have two applications. And when this is built into Unity, in essence, you can build different applications that share components by creating different scenes. And so here we effectively have a record scene and we have a playback scene. So the record scene is designed entirely to render the video within the head-mounted display and capture all the user data. And the playback scene is designed entirely in order to load that data back up and replay it so we can analyze it later. You'll also find if you jump into Unity, it is fairly drag and drop. So for example, here I have the test the test recording scene open, and down the left there's a number of items that have been basically dragged and dropped into the scene. So this includes things like the video player that I've built, and you have a number of parameters that we can toggle for that. We have our caption renderer that I've built, which includes the actual physical caption that appears in the scene. But we also have things like the HTC Vive camera rig. So if you want to make this scene work with the HTC Vive Pro, all you have to do is load up an asset that is the camera rig, drop it into the scene, and suddenly, as soon as you press play, it works within the head-mounted display. And I mentioned before, we have a separate thread that goes away running at 120 Hertz to do the data logging. And so these are all the components that make up the scene in essence. One of the other things that was quite important to us when we were building this to do user tests was that you should be able to put the head-mounted display on the user, and they shouldn't have to interact with the video that's playing back. So they shouldn't have to go through any menus or actually put any information at their end. We wanted the user to be able to do everything from the computer that they're set next to. And so a lot of the user interface as well is based around using different key presses. So you basically, once you start the test, if I press play, this is how we in Unity will always start the test running. And this is where it gets a bit exciting as well to see if it's going to work live. Sometimes it takes a little while to start. So let's, if we go slightly bigger so you can see the screen. In essence, as I move the head-mounted display around now, you can see that what the user would see is a nice little caption that says, please wait for the test to begin. And this gives the opportunity for the person operating the test to use keyboards, key presses to basically choose what test they want to run and to actually start it when the participant's ready. The participant doesn't have to do anything else other than put the head-mounted display on. And the other thing it does at this point is, as you look around within the scene, you do get an eye gaze trail from our software, which we ended up putting into the kind of please wait for the test to begin scene, so that the person running the test knows that the eye tracker is currently operating and it's doing what it's supposed to be doing and working successfully. So from here, I have to select the right window. I'm used to having more monitors. We can press a button that says I want to select a test. The screen goes blank, and it's basically waiting for the participant to, the person running the test, to press space and start the test. If I press that, you can also see where my eye gaze is as I look around. And we can run the test. And while this is happening, the whole system records that data and throws it onto the disk. So in essence, what that then means is we can change scene. We can go to the playback scene and say, actually, I want to play back one of the tests we've run. And within here, you'll find that you can change the parameters. You can say which test you want to load. And because the database stored the state of the system at every time code previously, if we now run that application and we select the scene again and we press play, what it will do is it will give us a trace of exactly what's happened and where that person's looked within that 360. So again, by separating out the two, it means we can now build, we can now effectively reproduce that test. And so if we wanted to put a new area of interest into the scene, or we missed something, or we want to analyze the data in a different way, because we can completely recreate that test, we can basically play it back, but change how we're actually now going to analyze it. And you'll see on the screen, when reading things like subtitles, our framework now automatically identifies words as areas of interest. And you can kind of see that the system's currently logging which word they were reading, when they were reading it, what they were looking at, and it's generating new text files again. One of the other interesting things that we came up with that kind of fell out of this is one of the reasons why I love working in this world so much, is by getting to this point and having a framework where we have a video player that has eye tracking built in, you also suddenly start to think about, well, what else could you do with this? And so, for example, what else could you use the eye tracking to do? One of the problems that people have is the navigation within 360-degree video, how you actually look around the scene to find the caption. Maybe we can do other things, so such as we can put a parameter in here that tells it to pause the video each time there's a new caption. And so suddenly, because we know where the person's looking, and we can extend this further to say, let's wait, pause the video until that user's read the subtitle, and then we know that the video can continue. And we've also extended further and looked at, well, if we've also got objects. So within this scene, for example, we know what the background sound is. We can basically, although we pause the video, we now have an attentive player where the video pauses, but the sound continues until the person has read that caption in the background. So it's not too disturbing that the video has frozen, because you're still hearing all of the background noise. And once the person has read that caption, the video then resumes. And so I'm not saying for 1 minute that this is a great way of doing it, but actually it's a really interesting idea for something that we need to test. We need to use the eye tracking framework to say, actually, does this result in people reading the text and the captions more easily? I, for one, we created quite early on a 360-degree video with people sat all around where they were reading, each saying a few lines in different positions. And if I turned the sound off and tried to follow the captions, I had no chance of finding the next caption in time and reading it before it even disappeared. And so thinking about moving forward, looking at things like attentive user interfaces, I tried the exact same video and suddenly found, actually, it worked really nicely for me. I could find the next person. I looked at the caption, they said the lines. I could then had time to look for the next ones, etc. So I appreciate that the schedule's a bit behind time. So I'm going to basically leave it there, but I'm happy to continue this discussion into the break into the lunch if anyone's interested in talking further about it. And then hopefully things won't be too behind the scenes. I'm also happy if anyone wants to see more extended demos or me go into more detail about how we've written the code and how we've put it together. Feel free to drop me an email at some point, and I'm very happy to jump on Zoom and actually go through some of that in more detail as well. But other than that, I'll leave it there and take any questions.